All right, I think this might be working. Can anyone see anything? I can't see anything because I apparently don't know how to use computers. Let me see here. There's a control room somewhere. It says I'm live. It's been 15 seconds. What's the buffer on this thing? All right. Something's there. Hey, everyone. All right. Sorry about that. That was, I would say inevitable, but I suppose it really wasn't inevitable because I could have tested with a scheduled stream before, but of course I didn't. I just scheduled with a proper live clicky button stream. So now we are here. We are together. Thank you very much for waiting. Whoever is actually still around, I'm actually going to tweet real quick because my alerts and notifications were totally wrong. So 1 second. How do you use computers? This is hard. All right. So this is very strange for me. Video in general is very strange for me, but at least when I have a proper camera, I can record myself and edit out all the weird problems that occur and all the weird things I say because I inevitably say some weird things or make weird noises or things just go wildly wrong as they did now. But this is a learning process and that's how I've learned to learn is to just jump in and figure it out as you go. So what I'm going to be doing here is going through a lot of what I do on a daily and weekly basis anyway, because making those polished videos that have cuts and everything else takes a whole lot of time. So I'm going to try to get into a rhythm of doing this type of live stream regularly, where I just basically do the stuff that I'm doing anyway. And I do a lot of reverse engineering and reverse analyzing and deobfuscating of JavaScript as part of my role at Shape Security because we deal with a lot of really sketchy JavaScript and we want to know what it does because usually it's malicious and we need to know how it works. So I do a lot of reverse engineering of things and I use a lot of hacky tools and scripts and manual stuff. So over the course of the past few weeks, I've been translating a lot of those into reusable libraries so that we can talk about them here and go through some of this together so that we can build a foundation for reverse engineering and deobfuscating JavaScript so that we can do more advanced things more quickly as we go. So if you have any comments, put them in here. This looks to be about 20 seconds, 25 seconds delayed. So I will try to stay on top of it so that I can just address questions as we go. So this first step here, we're going to be playing with JavaScript-obfuscator. You can view the online version at obfuscator.io if that ever loads. Another beautiful part of going live is that you just deal with everything that pops up. This is super. Yeah, we'll have fun together. All right. Obfuscator.io is loading. So this is one of those top results if you Google for JavaScript obfuscator. I'm not sure if actually this is even still maintained. I already have that loaded over here. Let's see. Yeah, so JavaScript obfuscator is not actually still maintained. But it doesn't mean that it's a bad project to start deobfuscating or a bad output to start deobfuscating because it gives us the foundation of transformations that we'll reuse over and over and over again. I think even though it's still not maintained, let's see, JavaScript obfuscator. Yeah, it's still the top result on Google. So people will still be using this for however, who knows how long. The obfuscations, some are relatively effective, but it's stuff that is somewhat easy to reverse. A lot of the obfuscations are kind of, they're fancy for show obfuscations. And actually, let me show you one. Well, I'll go through it as we walk through it as we walk through deobfuscating it. But this is what it looks like just transforming basic code. So you copy and paste your code here, or you can upload something, obfuscate, and it will do some magic eventually to obfuscate your code in what looks like fancy ways. As we wait for it, there are a bunch of options down here. These are the defaults, which is what we're going to be using because this is just what exists on the page when you first load it. The actual obfuscation defaults for the project are different, but we'll be starting with these because this is what most people will see first. Ooh, this is not very exciting. So let's string array threshold. Let's turn that up to 1. So the string array threshold is the probability of any string being randomized. It's useful to have that random itself because as you're running obfuscator on code, it will it will have unpredictable outputs, so that if you're writing code to automatically deobfuscate it, you're going to have to be a little bit more clever in order to make sure that you are resiliently deobfuscating a wide range of transformations. Let's see. So identifier names generator. Let's do mangled, rotate string array. Let's see what this does for us. All right, so this gets to be a little bit more interesting. I see it's pulled the strings over to this variable over here. It has a function here, and that function is called over here. So this is how we're getting those strings out. We're making a call to this function. We're passing it 0, essentially, and getting that string back. This is what I mean by a lot of transformations that you'll probably have to do over and over again, regardless of whether or not you're deobfuscating this particular obfuscator, because one of the common ways of obscuring the intent of code, especially like JavaScript, is to transform all strings into something that is not immediately recognizable. And that's just because when you're going through large swaths of code, the first things you're going to be drawn to are strings that are instantly readable. If you can obscure those or make them a little bit harder to understand, then it's more likely that somebody's first of all going to glance over your code and not understand that it's malicious, or just have to go through a number of steps to get through that. So let's jump over to some code. So this is the Let's see. Yeah, this is the script we're going to use. Script we're going to obfuscate. It is pretty basic, and it is certainly contrived. I tried to include a bunch of different aspects of JavaScript. Well, all right. Thank you for letting me know. You guys should be able to see the screen now. Now. How about now? I'll say that, and then 20 seconds later, you will be able to get that question and respond. We'll move on because I'm pretty sure that should be good. So these are this is the JavaScript that we're going to be obfuscating. Yes, it is a surprised Pikachu face when I see the comments. This is strange. This is very strange. I'll get more used to this as we go. I'm going to try to do this weekly. But yeah, it's very, very awkward and uncomfortable. This is far more terrifying and far harder to do than getting up on stage and presenting to hundreds of people. This is it's asynchronous. It's live. I can't go back and fix things. I'm getting strange delays in feedback, and then the communication back and forth. It's awful. It's horrible. So I hope that we eventually have more fun during this process. Anyway, going through the code that we're going to obfuscate. I guess back over to the website. So if you were following along at obfuscator.io, we were just going through some of the basic options in the web page. You copy and paste code in there. You press obfuscate, you get some output. You can tweak things over here to adjust that. We're going to be using the NPM library so that we can reliably obfuscate code locally without having to rely on the web page. So we can tie it to a particular version. We can set options that we want to set. We can make sure that we have a static seed so that as we're going through these obfuscations, we can reliably have a source to work off of. So anyway, this is the script that we're going to be obfuscating. It is contrived, like I was saying, and that is because reverse engineering anything in the real world, you're inevitably going to be playing with a fairly substantial chunk of code. And doing that in a live stream like this, I'm not sure how well that's going to work. So I'm starting off with some basics that we'll build up off of so that eventually, hopefully, we can get into some of the larger pieces of code and some of the actual malicious code that we've come across. But right now, that's too big of a bite to take. And to obfuscate, we are going to be using JavaScript obfuscator, which is what's powering obfuscator.io. We're going to be using mostly the default obfuscation options, which are right here. You can check that out on the npm package. Let's see. The ones that we are overriding here are just making sure that we're using some defaults that I once saw on the page. I'm not sure if they're default anymore. But it's basically mangling the identifier names instead of using hexadecimal identifier names. Going to be transforming object keys. We're going to use Unicode escape sequences because this is something I see a lot, and I'll show you what this looks like in just a second. And then rotating string array, we're setting it to false because that's going to make things a little bit more complex right now. We'll get to it, but let's keep it a little bit simple to start. So to get this, let's run this locally. Let's see here. So JavaScript obfuscator stage 1, node obfuscate. So this is what we get. So actually, let's jump this into obfuscated.js. Let's pretty print this because, I don't have prettier installed. We'll work with that for now. Actually, let's get that installed. So this is a burner laptop. I have a couple laptops. This is the one that I use mostly for researching malicious software and attack tools. So we use virtual machines on a separate laptop so we can thoroughly insulate what's going on. This is also a good streaming laptop because it is very minimally set up, and there's no risk of delivering anything to a live stream that I probably shouldn't. And actually, maybe at a later date, we can go through some of the attack tools because there are some really, really cool ones. Actually, we're a little bit late starting this stream, but if you guys want to do that later, probably till like 10 till, put some comments in the stream and maybe we can switch over and check out one of the new attack tools that I've been playing with. All right, so now we have Prettier installed. Let's go back to our obfuscated. Okay, multiple JavaScript formatters. There we go. So this is what it looks like. Structure is largely the same. You can see every single string is pulled up here because I set the string array threshold to 1. We've also set the seed here to 0. So if I ran this again with a randomized seed, we'll get a different output. We're just keeping this static right now. Let's see. So obfuscated. So the Unicode escape sequences are here. And these are literally just escape sequences. This is something, if you browse a bunch of websites JavaScript, you'll occasionally see JavaScript that starts off with something like this because obfuscation tools on the top few results of Google search results do this. And you can see companies that use those just by looking at the first line of their JavaScript to see if there are a bunch of Unicode escape sequences. So when I say escape sequences, I literally mean escape sequences. So if I were to go into the console right here, scam warning, take care when pasting things you don't understand. Understood. So if I were to paste this, if I could paste this, do I have Chrome? I don't know what's up with Firefox DevTools right now. Maybe it's a problem with copying and pasting. Normally I use Firefox, so this is kind of strange. All right, so let's go here. So I'm copying and pasting this code in here, var a equals a bunch of these strings, pressing enter, and now a is just those strings that the obfuscation was trying to hide. So this is one of those obfuscations that is just for show. There is zero value in having these obfuscated because it is so trivial to undo that it's something that you will rarely see done by actual attack code, actual malicious JavaScript. You will more often see this done by security companies and security vendors because it's just a for show obfuscation. You show that to a customer, it's like, yes, we have magical obfuscation. And there are some very, very big companies that do this. And if you're watching that, then come on, you should do a little bit better than this. But one of the things that it does do that is pretty annoying if you're trying to reverse engineer this stuff is extract all the strings to this variable and have it go through a function in order to extract those back during runtime. And that definitely makes reverse engineering a lot more difficult. You go through the code right here and you will have to manually replace these in order to figure out what's going on, and it's just kind of a pain. So one of the first things that we'll tackle as we are reverse engineering things is just the replacement of strings. This is a generic thing that you'll have to do over and over again with virtually any code that's trying to hide itself. So let's get started. Let's see, deobfuscate. I have an empty file right here. The way that we're going to be doing this is by parsing the JavaScript and then running it through a bunch of transformations. Now I'm using a library. Well, let's parse it. Let's see. I already have the shift parser installed. There are a bunch of different JavaScript parsers that you could choose to use. At Shape, we made the Shift suite of tools. We made it for a reason to make transformations much easier. And that is what I've grown accustomed to using. You could always use anything that's based off of ESTree. And then there are some other custom parsers which have extended ESTree for their particular use. I like this Shift stuff, and I built some tools on top of it, which we'll see in a little bit. All right, so we need to get our JavaScript ingested. So let's see, const file contents. Let me make sure that your comments are visible so that you all can yell at me appropriately. All right. I just lied. I did not make that visible at all. Now it's totally invisible. I've been using Macs for a really long time, and I still feel as though I'm not good at navigating how Windows work and how the Finder works and all these things. I still feel pretty stupid with that, but that's just me. All right. So file contents, we need our JavaScript. So let's say, I'm gonna be writing code that is not necessarily indicative of code that I would be writing in production. So feel free to not judge me as hard as you might judge me in other situations, because really, when it comes to work like this is very much hacky stuff, get it done sort of code. So it's gonna be what it's gonna be, and we're gonna move on quickly. All right, so we're gonna read file sync original.js utf-8. Make sure we are actually getting that. So that is the file contents. We're not parsing anything yet. Let's see if I'm writing code that actually runs. All right, so that's the original. Oh wait, we need the obfuscated. Obfuscated. All right, so we have that in. Now we're going to parse that to a tree. So we have our JavaScript parsed, and parses like this, they'll take a raw blob of JavaScript, go through it, parse JavaScript the way it was meant to be parsed, and then transform it into an abstract syntax tree, which is it's a data structure that represents the parts of JavaScript that make up JavaScript. If you have never played with an AST before or a parser, you can check out something like astexplorer.net, which gives you a visual interface to navigating this stuff. So let's see our obfuscated JavaScript. Throw that in here. Let's parse it the way, let's parse it with a shift parser. Let's also change it to parse it as a script. What happened? Something broke. All right, there we go. All right, so this is what we get. We have a script that starts off with 3 statements, which is the variable declaration right here, variable declaration right here, and this, whatever this is. So it's an expression statement, call expression, this immediately invoked function expression. And then to dive into any of those, you just keep on traversing the tree till you find what you want to find. So navigating JavaScript like this is going to be exactly how we want to be navigating JavaScript when it comes to purposes of deobfuscation, because we can't do things like straight string replacement or regular expressions, because the syntax of JavaScript is just far too complex for that. And if we rely too much on string replacements or regular expressions, then we will inevitably get into a point where we've done something wrong, and it's just there is always a limit to what you can do there. All right, so we have our JavaScript parsed. Where's my code? Deobfuscate. I need better names here. Deobfuscate, obfuscate, obfuscated, original obfuscated. All right, yeah, this is inevitably gonna cause a problem. All right, so we have a tree. We've parsed it. All right, so what I'm going to do is include a not public library. This will be made public imminently. This is in the process of going through the open sourceification. But the gist of this library is that we use shift query to query nodes and then just transform them. So you could do this all by hand, and this is actually what I was doing by hand. But I've formalized all my hacky stuff into a library so that I can just do it a lot more easily. And this is very nice for me. This is something I've been procrastinating for a very long time, but because we're going through this here together, I figured it was a good time. The way it works is basically just gives you a whole bunch of useful utility methods that act on a shift AST, so that you can rename identifiers, delete nodes, replace statements, recursively replace statements, insert statements before or after, what I'm calling unshorten, which is basically just uncollapsing variables. A lot of minifiers will do like a var w equals window. This will just reverse that. So it'll get rid of the w identifier and then replace all references to that with window. Let's see what else. So it uses shift query. Hold on, we can do that actually on the command line too. Shift query is a library I ported from esquery, which is essentially the same thing on top of the ES-tree AST specification. And it allows you to use CSS-like selectors on an abstract syntax tree so that you can query nodes much more easily. So let's see here. Let's do. You can install shift-query-CLI in order to play with this on the command line. So let's see. So we're going to look for deobfuscate.js, and let's look for all call expressions. Call expression. So that query will look for all call expressions in the source file and then output them as a list. And the command line, let's see, whoops, I don't have this set up the way I normally do. So on the I don't have iTerms set up normally. Does anyone watching know what the default key sequence is to go forward and backward? I normally set that up because originally there wasn't a way to do that, and now I don't know what the standard way of doing that is. So if you do know, please let me know. So if you pass it a -j, it'll output as JSON. So that way you can use something like JQ. I do not have JQ installed on this computer. So JQ, if you have never used it, you should. It is a JSON, command line JSON query tool. So you can use something like shift query to query a bunch of nodes, and then something like JQ to query out of there, and then something like the shift codegen.cli, which will then output actual JavaScript. So this is a really, really handy pipeline for extracting JavaScript from a source file, and then outputting it as just the little bits of JavaScript. That is useful for reverse engineering because there are inevitably some utility functions in JavaScript source that you can extract and then use yourself. So something like even what we're playing with right now in the obfuscated.js, like this function right here, we could extract this and then use it ourselves. In order to just get the power that function was providing for our own deobfuscation purposes. But let's see here. So deobfuscate. So refactor session. So on the const refactor equals new refactor session tree. So now we can do a refactor.print and see what we get. No deobfuscate. So even just by parsing and then generating code all over again, we get all of those lightly obfuscated strings out in the clear. So even doing nothing useful whatsoever, you don't need to use shift refactor. You could just parse it and then code gen the tree in order to get this level of obfuscation. So on terminal, it is option plus arrow key. It's not, though. That's what I have it bound to in my normal setup. Oh, escape F, escape B. Yeah, I've not trained my muscle memory to use escape in that way, and that's on me. That's my bad. Thanks, Jason, though. All right. So anyway, deobfuscation. So now we have a refactor session, and I built it this way because when going through large refactors, there are often times where you're going to want to undo some refactoring. So if you're doing this all in like an IDE, let's say like Visual Studio Code or something like that, you can rename things very easily here, like press Shift F2, rename things right there, and you get the ability to do a lot of what I'm going to be doing in code via the IDE. But if I screw something up, it's hard to reliably undo that without just doing Command Z over and over again. So let's say if I do something like rename this to file contents. Well, oh no, that still did the strange thing. All right, so now I've got 2 file contents. So now let's see, I want to rename that again. It's doing that properly. It was a bad example. And one thing that I'm learning live is that my brain is not working like it would normally work when actually coding. This is like live coding up on stage somewhere. Like this is just totally different. So I will troubleshoot that another time. What I was trying to show is that if you do a rename in an IDE and you clobber another name and then you try to rename something else again, you'll be renaming more than you intended. And those types of actions during large refactor sessions I guess they're common for me. And I liked committing my my transformations to code so that I would always have a reliable way of getting back to a refactor point over and over and over again. That way I can have a snapshot over here, and then I can go down an experimental route of reverse engineering to see if it plays out. If it doesn't, I can just go back to the code that worked and keep that snapshot there. All right, so let's see here. First, I want to be able to get the strings out from that initial variable. So the way that I can do that is by using refactor.query. So query is just exposing the shift query with the AST that we've stored in our refactor session. There's nothing really special with this one. So let's see, we need to start with a script. We are looking for the first child there. We are looking for an array expression. Let's see what that gives us. All right, so we have an array expression and we have all of our elements there. So we want the elements out of that. So let's see what we get with elements. Cool, now we have all of our strings that were in this up here. So shift query, I mean, this is originally ES query. I forget the original author. I know Michael Ficarra built a lot on top of it and I think took over some of the maintenance. But it is extremely powerful for querying nodes, for querying JavaScript ASTs. So if you play a lot with JavaScript ASTs, I highly recommend playing around with either ES query, shift query, and there's also a TypeScript query, TS query. Just a brilliant way of traversing ASTs. So we have our strings, and now what we need to do is we need to get, let's see. So we have our obfuscated JavaScript right here. So I probably jumping the gun a little bit. I know how these obfuscations work because I've played around with them a lot and I've seen them a lot. The way this works is this function right here takes in an argument. It can shift things right here and then returns the index from this this array as a result. So every call to be here or every call to whatever ends up being this function is a destringify operation trying to get those strings out of that array. So in order to get all those strings back to those original locations, we are going to need to find this shift. It's probably not critical for us to do that in this iteration, but since I know where these obfuscations go and this does become important, we'll play with this right now just so that we have that. That's another thing actually that's kind of important if you're reverse engineering JavaScript, well, I mean, probably anything, is that when you come across magic variables like this, it's worth treating them as something that is likely going to change, just so that when it does change, you've already accounted for it. That is something that we've seen grow in terms of protecting JavaScript on the web, is to make sure that it is constantly changing, because static JavaScript is just incredibly ineffective at deterring attackers, or deterring any motivated individual trying to get through this stuff. All right, so we need to get this. Let's go back to our deobfuscate. So we have our strings. Now we need the variable declarator that is, so we need the expression that is assigned to the second variable in the script. Do a variable declaration statement. We have a declarator, we have an init here, which is the function expression. We need to get into the body there. So first, let's see here. Checking on things. Things seem to be going mostly okay. So const, we need the destringify declarator. And that is going to be query, let's see. So variable, actually we can do it on the command line. So variable declarator. We want that where the binding is B. That gets us nothing. So variable declarator. Is that wrong? So variable declarator binding dot name. Why is that wrong? So we're looking for a type variable declarator binding dot name equals B. I feel like this should work. Shift query. So let's get all the variable declarators. Let's see. So all right, escape B. You say okay. All right. So we get what we're looking for. Oh, I'm looking at deobfuscate, not obfuscated. I told you those names were gonna bite me in the ass. All right, so now variable declarator binding.name equals B. There we go. So that is getting us what we're looking for. So that is the declarator we're looking for in order to capture this node. Variable declarator binding.name equals B. Now from there, we want to get the oh, you know what? First, let's rename that. We're getting a little bit late into the stream, and I want to show you a little bit more. So we want to rename destringify declarator. So this will automatically target the binding. Let's rename it destringify and then print that out. No deobfuscate. Syntax error. Syntax error in the selector. Cool. So now we've got this renamed. This is, it's not critical in such a small application, but when you're doing, when you're dealing with large chunks of code, renaming things as you go makes it easier to understand where you are, and also simplifies queries down the line. So you don't have to be very specific about where you're targeting. You just target it once, rename it to some unique identifier, and then you can just name it. You can capture those much more easily going forward. All right. Let's see. So now we need to get what we're looking for. We're looking to get the offset. So const destringify offset equals, so refactor. We're just doing a lot of querying so far, but that is, I guess, a lot of what we need to be doing. So we're going to query from the declarator. So that query from will just take in the AST we provide and query from there. So it allows us to scope our queries to something that is easier to manage than instead of the entire application. So query from destringify declarator. We're going to need to find, where is it? What are we trying to do? So we're trying to find a binary expression. So function body expression statement, binary expression, C. All right, so binary expression with a left of name C, and we're looking for the value on the right. So a binary expression. Well, for now, let's this is a small program, so we're going to be a little bit simple with our queries. So literal numeric expression. Let's see what we get here. keep that up here. Console.olg, which is rarely something that actually runs. All right, so I have far more literal string expressions. Oh, I'm still printing this out. All right, so we have a literal numeric expression with a value 0. This is what we're looking for. So destringify offset. We're going to grab the first item in that list there, and then grab the value. So now the offset should just be 0. Perfect. All right, so now we have the offset that is used in that function. And now that we have the strings also that function was grabbing from, we have all the information necessary to do a large-scale replacement of all those strings in the application. All right. So now we can do something like, let's see, refactor.replace. What we're looking for is, so we're looking for a call expression. You know what? Because we've, where is it? Because we've renamed this to destringify, we can very easily just specify that we are looking for calls to destringify and grab the arguments there. So we're going to look for call expressions with a callee.name of destringify. So replace. We should query that first. So this is where having those snapshots. Well, all right. So what I would like to build into this refactor program is a way to more easily print out snapshots. But I do not have that yet. So refactor.print. So we got this here. So we got destringify. I'm going to pipe that through to shift query. We're looking for call expressions with a callee name equals destringify. That should work, but just so we can get the practice of testing. All right, there we are. We got all the call expressions for destringify. So now we want to replace those. So we can pass a function to here. Let's see. So we're going to want to translate the arguments for the destringify, for the calls to destringify. We're going to want to pass them through our own crafted destringify method that uses destringify offset in order to find out where in the strings list those strings lie. All right, so I said those words. How do I translate those to code? All right, so I've got a call here. I want to, you know what? I'm going to need real shift stuff, actually. I have, so I built in a way to just pass source here. Let's see if this actually works. All right, so I'm going to pass it a string, and I'm going to have the value of that string be, let's see, so strings, node.params, arguments. Arguments. So it's just a list there. So strings node dash arguments 0 minus destringify offset. Autocomplete is failing me now. So I'm getting the element in the strings list that takes the argument from this node, subtracts the offset, and then I'll need the value out of that. Now that might work. Let's see. Whoops. Deobfuscate. Cannot read property value of undefined. I knew it was too good to be true. All right, so let's break this out a little bit. All right, so let's see, string equals, well, this is going to be undefined, so that's not going to be too useful. So let's see, node.arguments.0, we're going to need a value there. So that's let's try that again. We need the value there because what we have here in strings is a list of nodes, not a list of just strings alone. So when we access an element of that array, we need to grab the value of the resulting element. So we have a different problem now. This node expression.type is not a function. So I think that's a problem because I'm returning a string here, and I'm not sure that actually does work. So let's return a proper node. So here I am grabbing the shift AST library, which I already have installed via npm, which gives me access to shift node constructors. So I can recreate, or I can create instances of shift nodes and then pass those around. So what we're looking for is a new shift literal string expression with a value of this, in theory. Hey, it works. Look at that. So we've got every string replaced here programmatically. So this would be a great time to snapshot. We've got something that works the way we expect, and it's doing what we want. And we actually now no longer have a need for these two things here. So let's try to get rid of those. So refactor dot delete. We want a variable declaration. Let's see, variable declarator. Actually, pass it the destringify declarator. Why didn't that work? So the parser shift query. Oh, I guess maybe I didn't make it so that I can pass in a node there, only a query, which is disappointing. Let's see if this works. So I need to keep a list, a Jira list of all the things that I still need to do for this. All right, why? That didn't actually work. Because that is no longer what we call it. Cool. So deleting. We've deleted that destringify function because we no longer need it. And what we can also do is delete a because we no longer need that. So we've removed code that is no longer useful to us. Refactor also has a utility function. Let's see, convert computed to static, which converts all these computed member expressions to static member expressions, and wherever else you can have computed properties, it translates them to static properties. So now we have this, which is much easier to read. So let's see, output.js. This is very similar to our original file so far, and all that's really different is actually just changing some of the variables, which we can just do with further renames. But I think once you get to this point, you already have a lot of the value of reverse engineering in this particular script, and anything else is just to make it easier for other people to consume. So actually, this is a perfect time to stop. We are at the hour mark, and we have gotten to a reasonable snapshot of reverse engineered code. So going through this, this is 37 lines of code. A lot of it is taken up by boilerplate imports or initialization, and some liberal vertical spacing. But in general, like, this is now a reusable script to deobfuscate anything obfuscated by obfuscator.io, JavaScript-obfuscator, over and over and over again. So this is not even specific to this particular obfuscated file. You can start building out these scripts in order to just mass deobfuscate these things. Cool. Well, I'm happy we got to a point where this actually worked, and would love some feedback. So on Twitter or in the YouTube comments, whatever else, let me know how this was. Let me know what I could focus on more, whether or not I talked too fast, whether or not things were too slow at times. This is very much a process of learning, so I would appreciate your help. Thank you very much, and I will see you all next time.